Welcome to the course Design of Reinforced Concrete Structures. In today's lecture, we will solve a few problems on singly reinforced beams.
So, the first problem we will solve how to calculate the moment of resistance. So, before going into the problem, first we will see what are the steps you have to follow to calculate the moment of resistance. So, the first step what you have to do is you have to find out the value of XU limiting, that is the limiting depth of the neutral axis is to be found. So, in this particular problem, that is calculating the moment of resistance is a problem which is based on analysis. So, what I have told you, analysis, in an analysis all the data will be given. So, what are the data which will be given for us? They will be given the breadth of the beam, the depth of the beam will be given, the area of steel will be given, the grade of concrete will be given, and also the grade of steel will be given. When for the particular section all these data are given, if is asking to find out or analyze the moment carrying capacity of that particular section, then you have to find out first the XU limit. So, how you will find out the XU limit? The XU limit you will find out based on the grade of the steel. So, in the question it will be already mentioned, based on the grade of the steel you can find out the XU limit. So, if it is Fe 250 grade, then the value of XU limit will be 0.53 D. If it is Fe 500, then the value of XU limit will be 0.46 D. In that way, first step is you have to find out the value of XU limit. So, the next step is to find out the neutral axis depth, which is nothing but XU. So, in the previous lectures we have already seen how to find out the neutral axis depth. So, for finding out the neutral axis depth, what you have to do? You have to equate the forces of compression to the forces of tension, from which you will get the value of XU as 0.87 Fy into AST by 0.36 FCK into B. So, from this particular equation you can find out the value of the neutral axis. So, this is the second step what you have to do. So, next step 3. So, the next step what you have to follow for finding out the moment of resistance is you have to compare the values of XU and XU limit. So, while comparing the values of XU and XU limit, if XU is equal to XU limit, what we have already discussed in the previous classes. So, this section will be a balanced section. So, if it is a balanced section, the XU limit shall be considered while calculating the moment of resistance. If XU is less than XU limit, then such type of section is called as an under reinforced section. So, under reinforced section XU shall be used in calculating the moment of resistance. So, the third one is if XU is greater than XU limit, then such type of section is over reinforced section. Then XU limit shall be used. So now after comparing you will get to know whether if it is a balanced section or an under reinforced section or an over reinforced section. Then after finding out which type of section it is, then the last step is to find out the moment of resistance. So the formulas for moment of resistance with respect to concrete and with respect to steel are, so for with respect to concrete it is 0.36 FCK B into XU into D minus 0.42 XU. If it is a balanced section, what you will do? In place of XU, you will substitute XU limit. So in place of XU, you have to write down the value or substitute the value of XU limit for a balanced section as well as for the over reinforced section. If it is an under reinforced section, in the place of XU, you have to substitute the value of same XU. But for balanced section as well as the over reinforced section, the XU should be substituted by the XU limit. Here in place of XU, for balanced and over reinforced section you have to write down XU limit, and if it is an under reinforced section you can keep it as it is. And in the similar way, the moment of resistance of steel is found out from 0.87 Fy into AST into D minus 0.42 XU. So if it is an balanced section, you can either use both the equations and you can find out the moment of resistance, and if it is an under reinforced section, then the governing factor is steel here, then you can use this particular value, and if it is an over reinforced section, you have to use this equation for finding out the moment of resistance. Now let us solve a problem. The question given here is determine the moment of resistance for the section shown in figure. So here he has given us the figure and he is asking to find out the moment of resistance for the particular section which is shown here. And the grade of concrete is given as 20 Newton per mm square and the grade of steel as 405 Newton per mm square. First, let us write down the given data. So what is given here? FCK is given, which is 20 Newton per mm square, and Fy is given, which is 405 Newton per mm square, and the breadth of the beam is given, which is 250 mm, and the depth of the beam is given, that is the effective depth, which is D is equal to 310 mm, and the effective cover, this is the effective cover. Effective cover is nothing but the distance from the center of the reinforcement to the bottommost fiber is called as the effective cover. So the effective cover is given, which is 40 mm, and here they have provided 3 reinforcement bars and the dia of the each reinforcement bar is 12 mm. So 3 bars of dia 12 mm is provided. So here is asking to calculate the moment of resistance. So in the previously we have discussed the steps to find out or to calculate the moment of resistance. So what is the first step? The step 1 is to calculate the XU limit. So how we will find out the value of XU limit? XU limit value is based depending on the grade of the steel. So, what is the grade of the steel here? The grade of the steel is 415 Newton per mm square. So, what will be the XU limit value? It is 0.48 into D. D here is nothing but the effective depth which is given is 310 mm. So, XU limit will be 0.48 into 310, which will give you 148.8 mm. The next step is to find out the neutral axis depth XU. So, how we will find out the value of neutral axis? We have already discussed. It is 0.87 Fy into AST divided by 0.36 FCK into B. You have known all the values. Substitute all the values here. This is the step 2. 0.87 into Fy, you have known the value of Fy, it is 415 into AST. AST is nothing but the area of the steel. So, how many bars are available here, provided here? 3 number of bars are available. 3 into, what is the area? Area is pi d square by 4, pi d. D here is nothing but the diameter of the bar. So, what is the diameter of the bar? The diameter of the bar is 12, pi d square by 4, whole divided by 0.36 FCK. FCK is nothing but the grade of the concrete, which is 20, and B is the breadth, which is 250. So, if you will solve this, you will get a value of XU as 68 mm. So, this is the second step. Now, let us move on to the third step. So, what is the third step? The third step is to compare the value of XU and XU limit. So, from this what you can observe, that is XU is less than XU limit, because the value of XU is 68 mm and the value of XU limit is 148.8 mm, that is XU is less than XU limit. So, if XU is less than XU limit, what type of section is it? It is an under reinforced section. So, as it is an under reinforced section, the next step is to find out the moment of resistance. As it is an under reinforced section, the moment of resistance is governed by steel. So, the moment of resistance mu is calculated by using the equation 0.87 Fy into AST into D minus 0.42 XU. As it is an under reinforced section, what we shall use here? We will use the XU value only. The XU value only shall be used. So, the moment of resistance will be 0.87 into Fy is 415 and the area of steel is 3 into pi d square by 4. D here is 12 into 4 into D. The value of D is already given. What is the value of D given here? 310 minus 0.42 into XU. What is the value of XU we got here? It is 68. So, if you will calculate this, you will get a value of 34.40 kilo Newton meter. So, this is the moment of resistance for this particular beam section.